Appeals spiked 50x within hours when the ML classifier mistook satire for hate speech and auto-deleted it. The team assumed 99% precision on test data was safe, but the model had never seen satire. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's design a content moderation system. A content moderation system is a multi-stage pipeline that ingests every piece of user-uploaded content, applies checks, and decides an action. It must handle throughput at platform scale while maintaining low latency. Exact match filters are the fastest way to catch known bad content. They use perceptual hashing for images, SHA-256 for files, and keyword block lists. A Bloom filter reduces cache misses by 90%. Here's a simple exact match filter using a concurrent hash set. In production, you'd back this with Redis and a Bloom filter to avoid expensive lookups for non-matching items. ML classifiers assign probability scores for categories like toxicity and violence. Use a cascade, a cheap model first, then a heavy ensemble only for borderline cases. Multi-thresholds avoid a single naive cutoff. The article doesn't provide a code block for ML classifiers, but the concept is to use a lightweight model first, then a heavier one for borderline cases. Human review is the slowest and most expensive stage. Prioritize items with highest uncertainty and viral content. If queue depth exceeds a threshold, raise the ML threshold to reduce inflow. This priority queue uses uncertainty score to order items. The highest uncertainty items are dequeued first, ensuring the most ambiguous cases get reviewed quickly. Appeals are not optional. Design a separate pipeline with its own throughput limits. Auto-escalate after a time threshold to prevent backlog rot. A rising appeal ratio indicates false positives. Use Kafka to decouple stages. Cache predictions for viral memes. Pre-allocate partitions based on peak throughput. Regional deployment reduces latency. This orchestrator runs exact match first, then ML inference asynchronously. Based on the score, it rejects, flags for review, or allows. Note the multi-threshold, 0.95 for autoblock, 0.8 for review. Before labeling, translate human-readable policy into machine-actionable taxonomies. Decompose hate speech into slurs, dehumanization, incitement, etc. Each subcategory needs separate thresholds. This Python class defines a taxonomy with subcategories and an action map. The resolve action method uses confidence thresholds to decide the action. This structure maps directly to the pipeline stages. Standard accuracy metrics lie. A false negative costs orders of magnitude more than a false positive. Define a cost matrix and adjust thresholds to minimize total cost. This means intentionally overflagging. This function computes the total operational cost using a confusion matrix and a cost matrix. In this example, a single false negative costs $500, dwarfing the false positive costs. Run this weekly to detect drift. This is the same issue we highlighted at the start. Here's exactly why that happened. The ML classifier had 99% precision on test data, but was never tested on satire. Satire uses exaggerated language that overlaps with hate speech patterns. The classifier auto-deleted high-confidence items, causing a 50x appeal spike. The fix was to implement a 3-tier enforcement. High-confidence items are shadowbanned, visible only to author. Medium confidence go to human review, and a dedicated appeals pipeline with 24-hour SLA. Adversarial training data for satire was added to retrain the model. Never auto-delete content based on ML alone. ML can be wrong on edge cases like satire. Always have a human in the loop for non-obvious cases. Shadow banning is safer than deletion. A moderation system without an appeals process is a one-way door to user churn and legal liability. Design appeals from day one with auto-escalation after a time SLA. A single threshold is naive. Use multi-threshold. Items above 0.95 are auto-blocked, between 0.8 and 0.95 are flagged for review, below 0.8 are allowed. This reduces errors. The article mentions shadow banning as a safer alternative to deletion, but doesn't show how to implement it. Here's a concrete example of a shadow ban that hides content from others while showing it to the author. The article's Satire incident highlights the need for adversarial testing. Before deploying a model, create a test set of satire, parody, and quotes to measure false positive rates. Use tools like text attack to generate adversarial examples that mimic satire patterns. The article discusses asymmetric cost metrics, but doesn't show how to tune the threshold using a cost matrix. Here's a snippet that finds the optimal threshold by minimizing total operational cost. When something goes wrong, start with these commands. Check the audit log for the content ID, verify the rules applied, check inference health, and monitor pod CPU usage. Let's run through some common interview questions. Scale to 1B posts day, use Kafka, Bloom filter, GPU cascade, priority queue, trade-offs auto versus human, auto fast but brittle, human slow but context-aware. Handle appeals at scale. Separate pipeline, auto escalation, Shadowban first. And a few frequently asked questions. Why not use ML alone? ML fails on edge cases and drifts over time. How handle context-dependent content? Flag for human review with context. What happens during a crisis? Back pressure. Raise ML threshold, scale reviewers. To recap, a content moderation system is a multi-stage pipeline. Use exact match filters with Bloom filters, ML classifiers with a cascade and multi-thresholds, human review with priority queues, and a separate appeals pipeline. Scale with message queues and caching. Ready to go deeper? Up next, design a web crawler, then design Google Docs, then design Instagram. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.